What a great welcome. Thank you, everyone. Did you all miss me? Yay. Oh. But Hugh's been doing a fabulous job, hasn't he, Ben? Yay. Well, good job, Hugh. Okay, I'm going to try doing this. Let's talk about the best number there is, 0. And we've been doing a lot of history tonight, not intentional, so I'll try, for all of your benefits, doing a bit more math and physics. Aren't you excited? But you might have come tonight and thought, I give 0 fucks about the number 0. I'm just here for the beer. And fair enough, I don't blame you. But hold tight, and by the end, you might start being like me, and you might be talking about 0 with all your friends at all the random moments, and just throwing out wonderful, beautiful facts about this wonderful little number 0. And we're also going to dive into 0's dramatic twin, infinity, because the two of them have rocked math, science, philosophy, and even religion. And I'll take you through the story of how they've been feared, banned, worshipped, and killed for to see why something is actually nothing. So there was a time before numbers, just like there was a time before the alphabet. And before numbers, we actually had to decide that we wanted to count things. So the decision to count things happened around 10,000 BCE during the agricultural revolution. And the idea for counting came with counting sheep, counting crops, and figuring out which Sumerian owed you a beer. But nobody was ever counting 0 sheep, were they? That's kind of a weird thing to do. So 0 wasn't really important for a long time. But it was important to the Babylonians. So this is an area we've talked about in all 3 of the presentations, the Fertile Crescent that goes through modern-day Iraq. And the Babylonians had a numbering system where they needed something like 0. And interestingly, their numbering system is a base 60 numbering system. So ours is really a base 10, and that's because we have 10 fingers and 10 toes. You also see base 5 and base 20, because those also you can count on your hands and feet. But why base 60? ChatGPT told me to tell you that 60 is sexy. And 60 is sexy because you can get 12 factors from it. So you can have a lot of ratios using 60. And you can also get a 60-degree circle and 60 minutes and 60 seconds. So every time you look at that clock when you're bored during a meeting, you can thank the Babylonians for that random 60. And the Babylonian system looked like this. So there was 2 symbols, these 2 on the whatever side that is, and those symbols have different meanings depending on where they're placed. So they needed a way to separate it, to say, okay, well, if there's, for example, over here, 2 things in between, then it's a really big number, and if there's none, it's a smaller number. And so that's where the first 0 came in, just as a placeholder to say, this is where the symbol is, so you know how many thousands of whatever you're counting it is. 0 didn't really get its big break and level up until it reached India. So Alexander the Great went through Babylonia and then brought this idea of the placeholder 0 to India. And the Indians really liked nothingness. So the Hindu god Shiva is known as the god of destruction and also the god of nothingness. And the belief is that out of nothing, the universe was born. So having something that represented nothing was pretty cool. And this is when 0 really leveled up and started becoming a real number that was used in calculations and was actually pretty handy. And you can see down at the bottom, the numbers look quite similar to our numbers today. And that's because in the 700s, Islamic scholars took 0 and this numbering system and just ran with it. They're like, this is great, we're going to use this a lot. And one man, I'm sorry if I pronounced this wrong, Muhammad al-Khwarizmi, was really important in spreading this numbering system and the idea of using math to the rest of the world. And he wrote many books, including one called Al-Jabr wal-Makabel. And if you notice, Al-Jabr sounds pretty much like algebra. That's where the name comes from. So this bloke is the guy who's responsible for that course in high school that you either hated and traumatized you, or you might have been frothing over it, like me, if you're a nerd. And, those numerals he took, we now call them Arabic numerals, and that's what we use today, even though they really should be Indian numerals, because that's where they came from. But if we fast forward a few centuries, we get to Fibonacci, the guy with the famous sequence that you've probably heard of before. And he introduced the Arabic numerals, or Indian numerals, to Europe in 1202 with the book he published. And Italians are always the trendiest people. If any of you saw my talk on the evolution of eating utensils that I gave a couple years ago, you'll know that an Italian woman is the one who introduced the fork to the rest of Europe. And similarly, Fibonacci, an Italian guy, sounds like fettuccine, so he must be Italian. He's the one who introduced zero. I love the Snickers. What a good joke that was. And just like the fork, when zero was first introduced to Europe, everyone hated it, especially the Catholic Church. They said, it's the work of the devil. And they're like, no, we don't want that around here, none of that. But the bankers and merchants loved the easy calculations you could do with these Arabic numerals. So because money was involved, they kept it around, and all the resistance. It didn't matter. Now for the fun part. Zero is a total math outlaw. So if you add zero to anything, nothing happens. If you multiply by zero, instead of getting bigger or smaller like normal, it just collapses the number line to 1.0. And if you divide by zero, reality breaks. Anything becomes possible. The reason I'm giving this talk is I read a book called Zero, the Biography of a Dangerous Idea. And the best quote in that book is, "See Appendix A for proof that Winston Churchill was a carrot." And what the author does is he has a proof where he divides by zero, and then he can prove anything. So he proves that Winston Churchill has no legs and is orange and looks like a carrot. Anyway, zero is so disruptive when you divide by it that mathematicians usually avoid it at all costs. Like a friend who always turns a casual get-together into an existential crisis. Speaking of crises, let's talk about Pythagoras, the famous Greek mathematician. So you all probably know his theorem, a squared plus b squared equals c squared. Yeah, he didn't invent that. That was the Babylonians over 1,000 years earlier. What Pythagoras did do was start a cult. Very cool, super cool. And he believed numbers were sacred, reincarnation was real, and beans are evil. Either because they look like tiny embryos, or because they made him fart. We'll never know. But he also banned his followers from eating them too. And he really, really loved geometry and proportions, and he believed everything was like sacred ratios. And so the symbol of the cult was a number shape, or the pentagram, a 5-pointed star. And this is full of the golden ratio, which was Pythagoras' favorite number. Pythagoras found beautiful ratios everywhere and thought that they controlled the universe. Everything had shape and was connected in his opinion. So what shape is zero? Nothing? That can't be. So zero can't exist. Pythagoras' favorite shape was the square, which he called the perfection of all numbers. Each side represented one of the elements, and it was just beautiful, perfect, lovely. One problem was the diagonal of a square contains a square root of 2 term, which is an irrational number. And that means you can't turn it into a fraction. It just goes on forever without repeating. And the cult had a meltdown because of this number. They thought everything was orderly and perfect and rational, and finding this irrational number was like mind-boggling and really bad for their whole messaging. But actually the golden ratio, which was their favorite, that's also an irrational number. So these irrational numbers just kept showing up in all these different places, rearing their ugly head, and making the cult really nervous. One bloke named Hippasus, who was a mathematician and cult member, he finally spilled the beans. And what did he get for it? A death sentence. Pythagoras supposedly sentenced him to death by drowning. As for Pythagoras himself, he supposedly chose to die because of a group of angry mobsters instead of running through a field of beans, because those pesky beans were no good. Definitely don't go there. And numbers to him were such serious business. All right, let's change focus slightly and talk about the cosmos, so we can think about how small and insignificant and zero-like we all are. Pythagoras had the idea that everything revolves around the earth, and everything revolves around the earth in perfect, orderly spheres. And because everything's connected, these spheres, when they move, create music, which is quite a lovely idea to think about. And the philosopher Aristotle really liked this idea and model, and he built on it. So Aristotle said that what moves these spheres? So if the earth is in the middle and the earth is stationary, why is everything moving? Well, maybe it's the sphere immediately bigger than the one in the middle. And so then you get to the outside, because the outside is this big blue globe with little points in it that are shining light, stars. What's moving that? God. Yep, this is our perfect proof of God. God is moving that outer sphere, and then all the inner spheres get moved, and then we get to Earth. And because this was such a Loctite proof of God, this model lasted for almost 2,000 years, and it was accepted, promoted, and killed for. Of course, I wouldn't be talking about it if zero weren't involved. So Aristotle hated the idea of infinity. He had this model which had a finite outside, and therefore there could be no infinity. And therefore he said infinity was just a construct of the mind. It can't be real. There's no way for that to happen. And if there's no infinity, there's no void, there's no zero. And so the idea of a vacuum, which is pure nothingness, is impossible. Nature would never let that happen. The alternate theory at the time was that of the atomists, and that's kind of the foundation of the model we accept today. There was the idea that there's particles that are called atoms that are floating around in empty space. And this model is full of the idea of zero. So Aristotle absolutely hated it. The Christian church was so enamored by Aristotle's proof of God, they tweaked the Bible to fit it. So the creation story talks about coming from a chaotic void, and that was changed to, well, it's not really a void, it's just kind of a void. But then in 1277, the Bishop of Paris said, hey, God's omnipotent, so if he wants to create a vacuum, he can create a vacuum. Fast forward to 1517, and we find Martin Luther on the Privy, which is a type of toilet. Shockingly, the internet did not have a picture of this, but it did have this picture of Einstein. So we'll just put Martin Luther's head on top of it. And Martin Luther was a notoriously constipated German monk who shook up the Christian church. What he did was nail a list of grievances to the door of a church, and supposedly the idea for that came when his bowels finally released. Around the same time as this, Nicholas Copernicus and later Galileo Galilei said, maybe the Earth is not the middle, maybe it's the sun that's the middle, and then all the other planets, including Earth, go around the sun. And at this point, the Catholic Church was losing followers from Martin Luther, and then the scientist stuff was making proof of God questionable. So the only rational thing to do was to declare zero a heretic, bring back Aristotle's model and proof of God, and kill anyone who questioned this. Bring on the Inquisition. In the 1600s, we finally get a defeating of Aristotle. Galileo's secretary, Evangelista Torricelli, accidentally created a vacuum when he overturned a thing of mercury into a trough, and then there was empty space, which was a vacuum. And so since zero naturally appeared in this vacuum form, zero wins and was welcomed to the West. This opened the door for zero's big break, calculus. And it was invented in the 1600s by both the Brit Sir Isaac Newton and a German lawyer and philosopher named Gottfried Leibniz. Now we use Leibniz as notation, and it's full of zeros and infinities. And it relied on blind faith because you're basically dividing by zero, which normally makes a mathematical apocalypse. But for some reason, it works. So it's time for a quick math lesson to learn about calculus. Yay! Integrations for finding the area under the curve. And in this case, if you use smaller and smaller rectangles, you get closer to the real answer. So if you use an infinitesimally small width of rectangle, you get a really accurate answer. But that's basically just adding up a bunch of zeros. The opposite of integration is differentiation. And with differentiation, it's a divide by zero issue. So normally for calculating a slope, you have 2 points and you calculate the slope of the line. With a tangent line, like on the bottom, you don't have 2 points, you only have 1. So you end up dividing by zero. But you can differentiate and find the answer. So in the 1700s, they came up with the idea of limits, which is like a baby approaching the edge of a bed. They're going closer and closer and closer, and you take the moment right before they fall to the floor. That's what a limit is. And calculus is important for all sorts of things: physics, engineering, the stock market, all of that. So now let's look at some other fun places zero shows up. The first is absolute zero, which is the coldest possible temperature. And essentially, it's a container of gas that's drained of all its energy. Scientists have gotten really, really close to getting to this point, but they haven't been able to because the heat or light from the container or the things they're using are like an annoying party crasher, and they always get everyone re-excited, so it's never zero energy. And then we have black holes. Black holes are when a star collapses, and they take up zero space, but it still has mass, so it rips a hole in the space-time continuum. And there's lots of interesting and troublesome properties, which I'm sure you all are very well versed in, so we won't go down that black hole today. Then there's the Big Bang, which is obviously time zero, when nothingness became somethingness. And both general relativity and quantum physics attempt to explain the idea of the Big Bang, but zero causes trouble yet again. So scientists have solved this by banishing zero from the universe. They use the idea of string theory, where instead of having zero-dimensional spots, you instead have a loop, which is one-dimensional, and you are able to get rid of zero distance and zero time, making things easier to deal with and unifying quantum physics and general relativity. Unfortunately, it's way too small for us to currently measure, so we have no idea if this is true or not. Lastly, we have zero-point energy, aka the energy of empty space. So in quantum physics, things are never entirely still. You have tiny energy fluctuations constantly. And you can measure this zero-point energy by using the Casimir effect, which is two metal plates that you put in a vacuum, and then there's blocking of some of the energy fluctuations. So you can see there's like lots going on either side and not as much in the middle. So the stuff on the outside pushes the plates together, and you get free energy from this. One more quote from the book is, "More power than is stored in all the coal mines, oil fields, and nuclear weapons in the world is sitting inside the space of your toaster." Pretty amazing. And obviously people are trying to harness this, and nobody's really been successful to date. But hopefully we tap into this free energy at some point. Oh, and of course there's your bank account, the real-life demonstration of zero's power, usually right before payday. One more slide, sorry. Zero started as a nobody, ignored, feared, banned, but it fought its way to the top and changed how we do math, reshaped science, and even rewrote our understanding of the universe. So hopefully now that you've heard this, you have a bit more appreciation when you see zero at a crossing sign, in an equation, or in your bank account. Let's cheers to zero. I'll just hold it, yeah.
Any questions?
Why are accountants called bean counters? I don't know. I have no idea. Maybe it's Pythagoras' fault. I just read this one book. That's where all of my knowledge about zero came from. So, any other questions? Zero questions. Wonderful. Thank you so much for listening.